Hi guys, it's Cliff here again. How you all doing? Still on a big production run of parts for the impact tolerant touch probe. Doing big runs of parts slows down my ability to assemble and supply in the short term, but in the long term it increases my ability to supply. Although when my production gets held up because I have to do other work for my contract tool making and parts business for my valued long-term customers, that slows things down as well. Anyway, in this video I'm going to be going through tips and tricks that seem to be all of a budget nature. So if you're feeling a bit tight in the wallet this week, it could be something of interest here for you. So in this video I'm going to go into how to make your own lap for finishing out lapping holes, bore lapping, a very cheap tooling tightening fixture, a cheap way to make a height gauge and a quill gauge for the quill on your mill and tailstock, and one or two things like that, including how to produce grinding abrasive powder for zero cost. Alright, cheers. I've talked in past videos about lapping, stoning and honing. Just touched on it briefly. It's a huge subject and you could probably do 10 videos or a couple of books on the subject. So I'm just going to touch on it again here in regards to how it relates to the impact tolerant touch probe production. It's one of the key skills that you learn in tool making and mechanical machinery reconditioning. Here's some laps here showing past lapping jobs. Here's some hones, here's some abrasive compounds, and here's polishing stones used for polishing injection molds. I'm going to talk mainly in this video about lapping, and a lap is typically a metal mandrel which is expandable with, for example, a tapered plug and is split, and it carries, here's another example of it here, and it carries abrasive particles and is rotated inside the work for final removal of metal. And you can purchase or obtain abrasive particles in many different forms. Aluminium oxide in a oil slurry is a common one, or in a grease slurry, for example in valve grinding paste, or diamond paste, which is diamond particles of various abrasive sizes, and diamond powder, and many other forms of abrasive. Normally you'll do your lapping with aluminium oxide abrasive particles in an oil or grease based compound that you can just purchase, you know, whatever grade you want. 700's quite fine, 360's quite coarse, 600 diamond is sort of medium grade, and you just purchase that. Quite cheap to get a big tin of it even. But if you want some dry powder, you can also buy dry powder, but if you just don't have any on hand, or you don't have any abrasive particles on hand, you can use a bench grinder. You want to use a very fine wheel and just dress a little off with a diamond. I'll just show you how you can do that. And if you want to produce your own abrasive powder, for example in this case I want a water-based lubricant to go with the powder, so I won't use an oil-based slurry product that's already pre-packaged. I just want a dry powder. You can put a little of your lubricant, whether it's kerosene or in my case it's a synthetic water-soluble cutting oil, into a container and just dress a little off a grinding wheel. Just putting that. And you'll quickly build up a mound of aluminium oxide, in this case abrasive particles. So the impact tolerant touch probe arbors have got centers in them at each end to allow me to cylindrically grind them, and during the heat treatment, during the machining and then heat treatment process and then shipping process, it's likely that there'll be some form of damage. There'll be oxide or burrs or burnt on oil and so on that are not an ideal surface for running between centers for best practice. So what you can do is turn a wooden lap, in this case, or brass or steel, but in this case it's ideal to use wood, at the 30 degree, 60 degree included angle. Put a little bit of your abrasive on the surface and then just quickly lap the centers to remove those burrs. It doesn't take much to do that. And now we will have lapped centers. Now, in addition to lapping the centers, I also want to lap the inside diameter of the arbors, because the impact tolerant retract mechanism runs in there, and I also don't want burrs and high spots from the machining and burned on oxide and burnt on oil and so on. So I made up another lap, and this lap is just out of soft metal. You could use brass, I've just used mild steel, and turned it to about 2 thou or 500th clearance of the bores to allow room for the abrasive particles to go between. And you might think, oh well, that's not going to work, because the arbors are much harder than the soft steel, and surely the soft steel will just wear out. But what actually happens is that the abrasive particles are very hard, and they embed into the soft steel, a little bit like gravel presses into plasticine or putty, and it sticks on the soft mandrel or lap and scours the hard part that you want to actually lap out. And you can file some flats on it as well, which help to trap the abrasive particles that are too large to fit between the lap and the work. Let me show you that in operation. So I'll rotate the job in this case, because that allows a complete internal circular lapping process. I'll put a little bit of the abrasive particles on the lap. And now moving it at quite low RPM and sliding it lengthways, I get a figure 8 lapping process until I can feel it hitting on the, you might be able to hear that, on the face, because there's 2 diameters. And then I know that the shape is being completely lapped. Now, that's not to be confused with finished lapping or honing. That's just high spot lapping. All I'm doing here is taking off the high spots that I don't want there, and that's best practice prior to assembly. That should be done for heat treated components where you've got mechanical movement between 2 parts. Now I can, and the reason why I used a slurry made up out of grinding paste is that I can use a solvent or an oil in this case a water-soluble synthetic fluid, grinding fluid, that I'm later going to use anyway so that it's compatible, and I can flush it out. And flush out all of the abrasive particles and the cut metal particles, and then blow that out with compressed air. And the inside is not just lapped but also polished and cleaned. This is a good example of a sort of optional best practice procedure. You can see here the polished center surfaces on the ends, and the inside bore has had its high spots lapped off and any burrs removed. Now, this sort of best practice procedure takes time and adds to the cost of a product, and this type of procedure is just left out completely with a lot of low-cost manufacturers. They just make the parts, the running parts, of bigger clearance, and so you've got burrs running against burrs and hard metal burrs running against soft metal parts, and you've got enough clearance for it to work, and it may have some grease in there, and you get by and it works for a while. But this is the reason, one of the reasons why the product is a low price in the first place. When I show lapping and polishing in the lathe, I keep forgetting to point out it's really important to put a rag down on your bed to keep the abrasive particles from falling onto the bed. You really don't want them getting between the carriage and the bed, or into the screws or bearings and so on. Just be really careful. And then when you finish the job, wipe your chuck jaws down, because they'll have a coating of abrasive particles as well. Because a lathe is not designed to resist abrasive particles in the same way a cylindrical grinder is. In a cylindrical grinder, the table slides over the top of the bed slideway, and so that any abrasive particles flow clear of that critical sliding surface. If you're lapping to a specific diameter and you want the whole surface to be highly finished to an extremely accurate diameter, you probably need a expanding lap, something like this, that you can tweak up bigger and bigger until you would obtain the exact size you want. What I'm talking about here is something pretty basic. It's just taking off high spots, and although the work will wear, and although the lap will do quite a bit of cutting and the work will be lapped, the lap itself will wear as well, and it'll become smaller and smaller. You can get round that to some extent by rotating the work and holding the lap still, and that way it's lapping over its entire internal diameter, even though the gap is increasing. You can bias it off center, because you're only taking off high spots, burrs and oxide and so on. But for precision lapping, it's quite a different process. I'm not sure if I mentioned that this is another reason for lapping, is that the heat treatment process obviously heats the work up to 800 or 900 degrees C. You know, I'm not sure what that is in Fahrenheit, but it's well into the red hot temperature. And of course you get metal distortion at that temperature, and then it's quenched by one means or another depending on the type of alloy steel, and that causes distortion. And so another reason for lapping hardened parts is to remove at least the high points of the distortion, even if you're not lapping to full diameter contact. Well, I don't want lapping and honing to take up the whole of this video. It's supposed to be about workshop tips and tricks. I'm sure most of you have got your own way of loosening your TTS cutter holders and other types of cutter holders, and I know there's all sorts of fancy little fixtures you can use. I just thought I'd show the way that I've been doing it lately, in case some of you haven't stumbled onto it. An easy way of doing it that doesn't require any equipment. Really pretty simple. It's just using a vise. You can put in these magnetic type aluminium jaws. I've just got permanently, whoa, how many thousand times has that happened? I've just got aluminium jaws held in with little dowels. So anyway, you hold your cutter holder just lightly on the 3/4 inch TTS diameter, not enough to hurt it, but just enough so it doesn't fall over. Put your spanners on, and you can turn it in there for the best orientation, and then just use your body as, so you're not just using arm strength, but you're using your body and leaning against your hands, and you can snip it undone. Put it together and snip it up. While we're on simple budget ways of doing things, some of you will have seen this in the background, but I don't know if I've actually done a video on it. It's just a simple depth gauge made out of a basic budget Chinese 12 inch or 300mm digital vernier, and you can just screw a base onto the head. I'll show that in a minute, and that way you can offline measure your tools. So you make up a little bush, sits on the deck, zero it there, it's zeroed at the moment. Then you can just measure your tool height, your tool length, because this surface represents the spindle surface, and this gives you the height from the critical TTS flange height to the end of the tool. Instead of buying an expensive depth gauge, a digital depth gauge, if you're on a budget, you can just use a cheap, what would they cost on eBay in the US, 20-30 US dollars, cheap digital vernier, and just bolt it onto the base. And all it is on the base is a couple of pieces of aluminium that clamp on the end of the vernier and then screw to a block of steel. Or it could be aluminium, but steel would wear a little bit better. So it's just a simple, cheap way of doing it to get you going. Maybe you're just starting and you're on a budget. And while we're on the subject of cheap digital verniers, the little 6-inch one's probably even cheaper. It might only be 10 or 20 US dollars delivered, something like that. Really handy for on quills too. It's a really good idea to have one on a tailstock. This is just a split piece of metal. It clamps on the end of the tailstock quill where there's no traverse, and then I've just sawn off and drilled through for the screwing the jaw down on the top there. Oh, puffed out. That'll teach me for doing exercises. And that just saves you memory when you're deep hole drilling. You know, you can just get those depths really quickly and easily. Okay guys, thanks for watching. Catch you again. Cheers.